All right, shortest part two ever. Um, just ran out of time on that last one, but basically all that's left here now, we looked at the expected value and another game that wasn't fair, especially for the player. They're losing 50% on average each time. You could approach this in one of two ways, whichever one sings to you better. I find that more students kind of focus on this one just because, you just subtract off the loss at the end and you're good to go. Or I should say the amount you pay no matter what, and you're good to go. But if you like the net gain approach, either way, may try them both, see which one sticks to you better. But you can use either one and you'll obviously get the same answer. So the law of large numbers, basically knowing the expected value is part of what makes the casinos profitable. Like these games here, this is a game, oh yeah, casino, be all over that. If you look at the ones on the left side here, this one, nope, casino isn't going to want any part of that one because they're not seeing a negative for the player. And this one, yeah, this would be one that the casino would pick up on. So when the casinos are designing their games, new games to get people in the door, they're looking at the expected value first and saying, what is the expected value of this game? But trusting law of large numbers is arguably an even more important part because these probabilities that you use are theoretical probabilities. 1 out of 6 for seeing a 6 show up on a die roll. 3 out of 6 for the even. 4 out of 52 for the aces being drawn. So you're looking at theoretical probabilities there, what should happen. You don't know what's going to happen yet because this is in the future that you're looking to plan. So the casinos then are like, okay, well, we know the law of large numbers means that with larger numbers of trials of an experiment, the observed empirical probability of an event will approach the calculated theoretical probability of the same event. So in short, if you did this enough times, maybe thousands of times, you would see that the fraction of aces that showed up would be 4 out of 52, or very close to it. You would see that the number of sixes that showed up on die rolls would be 1 out of 6, or very, very close to it. You might be off by some, very insignificant decimal values, but you're going to be very close to it. And as you go through this experiment that I'm having you do in our class in the discussions, I'm hopeful that we'll have enough large number enough to kind of show you that the probabilities do get realized, that we're looking at. So law of large numbers, expected value is essentially what makes Vegas Vegas and any other gambling establishment successful. And basically, this is what ties together the empirical and the theoretical. I mentioned that earlier too. We're going to see that later. Law of large numbers. The more you do something empirically, the more you are going to see it approach the theoretical. Okay, so that's part 2. And if you have questions, as always, please ask. I can't help you unless you ask because I'm not a mind reader of any sort.